All right, today what we're going to talk about is finding the 5-number summary on Desmos and calculating outliers of a set of data. So I actually already showed you how to do Desmos from before, but here's a little example of what we were talking about. So for this, to do it, what you're going to do is you're going to type in whatever letter you want here, and then you're going to do brackets. You're going to enter in all your data sets and you're going to end it with the bracket. Then you're going to go to your keyboard, which mine's hidden right here. Go to the little keyboard down there. It's a beautiful keyboard. And then you're going to go to functions. Once you get the board of functions, it's going to pop up and you're going to click the Stats tab. And under the Stats tab, you're going to enter X1 so that your line reads Stats X1. So you can do a table, or you could do what I just showed you where you do a letter there. So either way works. But if you're to go onto NC Desmos right now, or onto Desmos, and enter in all of these, you could do either what I did here, where you do any letter equals, or you could go to the table and then enter in your data under X1. So either way works. But either way, I went through, I entered those in, and then when I did enter those in, it looked like this. And what it was able to show me was that 10 is the minimum. That is the smallest number for your range, which that makes sense because 10's right here. That's the smallest out of all of them. We said the first quartile was 73. Now remember, this is 25% here. And then once you get here, this is Q1. So we said the first quartile, so this is kind of the first halfway point of the first half of it. So the first quartile is 73. So if we were to line all these up from smallest to largest, 73 would be in the first quarter. The median, which is the middle number, would be 81. And remember, median is also known as Q2 because that's the second quartile, or like I said, the halfway point. And then Q3 was the third quartile, and that's the if you were to look at the second half, it's the midpoint of the second half. And then lastly, your max is 100 because that is the largest number out of all of the data. Now, if you were to look, this information is, if you were to think of it here, your information is going to be skewed left because most of the data is on the right side. So now any point that is more than 1.5 interquartile ranges below the first or above the third, so that's what we're going to look for, it's an outlier. So steps to proving a number is an outlier. So remember we said an outlier is something that doesn't fit or go with the pattern of everything, but we're going to get a little bit more specific with it. So we're going to take this data, and again you can plug this into Desmos, and when you plug that into Desmos, it says to find the first quartile. Well, Q1 is 81, Q3 is 21. So what we're going to do to find the IQR, which is your interquartile range, you just take Q3 minus Q1. So that's what I did here, and I got it equals 13. So to determine your upper and lower limits, you're going to multiply the IQR by 1.5 because we said if it's more than 1.5 interquartile ranges below the first or above the third, it's an outlier. So we took 13, which is where we got here, and we're going to multiply by 1.5, and we got 19.5. Now find the upper and lower limits by adding Q3 and subtracting Q1. So remember the lower limit, because we said it has to be below the first quarter. So we're going to take the lower limit. We're going to do Q1 minus IQR. So we got negative 11.5. Now Any number in the data set that falls below this lower limit is considered an outlier. And then to find the upper limit, because remember we said it needs to be above the third quartile, is we're going to do this very similar, but we're going to do Q3, and since it said above the IQR, that we're going to do plus 19.5, and I got 40.5. So any number in the data set that falls above the upper limit is considered an outlier. So determine if any of the numbers in the data set are outside of our lower and upper limits. If they are outliers. So if you were to look here, for the low, we don't have anything that would match or fall within there. But for our upper limit, oops, I didn't write that in. This would be upper right here if we're looking here. So upper, 45 is an outlier because we know that 45 is higher than 40.5. So in this instance, we only have one outlier in the upper limit, but we don't have a lower limit outlier because we don't have anything that's below 11.5. All right, and now, just so you know, you could have one, none, or many outliers, and that's just all you need to do. So again, go on Desmos, you're going to either enter a table where you do the plus and you would do a table and enter in your stuff in the table under X1, or you can go type any letter and then do a bracket around your data points and then go to function and go under stats, go under box plot, and then type whatever letter you have here, go into there, and then that's going to give you your diagram of your outliers. So you know that this would be your min, this would be your max, oops, this would be Q1, this would be the median or Q2, and this would be Q3. So then you can go through and find all your information that way. And then to find the interquartile range, multiply it by 1.5, subtract it from Q1 because it's below that, but add it to Q3 because it's above that. And anything that does not go outside, then it's, or excuse me, if it goes outside of the lower upper limits, it is an outlier. And then that was a quick, easy notes for today on finding the 5-number summary and calculating outliers.